Next up, guys, we're going to talk about the user interface. Okay, so we talked about like the model space and everything like that, but I want you to understand where to find things, and you can actually start to play around with it if you've got the time before next class. So in order to do that, I'm going to leave. Let's see, I'll leave floor plan open, and I'll close these two sheets, and I'll leave the elevation open. Okay. All right, so the user interface, right? I pulled out this project browser. The project browser is your, I guess it's like your road map or your site map if you guys have ever done any web design, right? It just has all the elements and where they're categorized. The project browser usually gets docked. I usually dock it on the side here, and it doesn't seem to want to dock for me. Put it up there. Let's see. Oh, I didn't want to do it that way. I don't want to do it that way either. All right, whatever, that'll work. All right, so that's project browser and properties. So the other one that you have there, and I just noticed that the window is a little funky down the bottom of the view. Let me raise this up a little bit. So when I pulled it back over and I docked it on the top, there are these two tabs that appeared at the bottom. There's properties and there's project browser. So properties is the other roadmap. Okay, so think of the project browser as your roadmap to the whole file, and think of properties as your roadmap for each element, right? It's like it's showing you all of what's called a parameter, right? These families have multiple parameters that are built into them that you can modify, okay? And it's a little bit different than, say, like a grasshopper parameter, or if you guys ever used Form Z, like the purely geometric parameters. It's much more intelligent than that. So let's take a quick look at, like, if I have nothing selected and I happen to be in a view, right? Technically that means I have that view selected in a way, right? So that's my default in that view. So the floor plan has parameters. The floor plan view has parameters. Those parameters include things like the graphic settings, other elements that it might show, like underlay. You can underlay like the second floor on the first floor, or the first floor on the second floor. The extents of the view, like what's being shown versus what isn't being shown. Identity data, I guess, is just like how it gets categorized. I guess that's a way to describe it. This is how you can like schedule it and stuff like that. And then phasing. Phasing is important. We will talk about it at a certain point. I don't know that I want to get there with you guys yet. Okay, I'm just showing you the user interface here. Okay, yes? They're gone. Okay, good thing. So when you go to view, right? So up top, if you guys happen to close these, like you hit this little X and it's missing, go to the View tab and go to this User Interface button. And then these are checkboxes for which views and stuff are showing. So make sure Properties and Project Browser are checked on. Okay, make sure you check on Properties and Project Browser. Okay, so most of you, if you didn't close it or something, sometimes our software here, like with Rhino, when it boots up, some of the tools don't boot up. That's possible it would happen here. I would think with an Autodesk product it might not do it as much, but anyway. So that's that. Let's see. All right. So yeah, so we've got a roadmap to the file and all the things in it, and then we've got a roadmap for each of the things in that file. The other thing that I guess I want to talk with you about here tonight is like, what are the various types of elements that we work with, right? We have architectural elements. That's why we have an architectural tab. We have structural elements. We have, and I'll just kind of click into that tab real quick so you can see, right? Like structural stuff. And then systems, and then a bunch of management stuff. We'll talk about that. Annotations, dimensions, text, tags, stuff like that. Massing and site elements, analysis elements. All these things are tools that we can use in order to create really smart geometry. in the sense that, like, if I'm drawing a wall, right, I go to architecture, I click on wall, and right now that just says basic wall, but let's go to something that's a little bit more complex, like an exterior brick on metal stud. Okay, we're going to get into this later, don't worry guys, but it's a relatively complex wall type. I click that, I draw my wall. Oh, it's outside the view. There we go. And when I go there, I can't really see it right now, but let me go down to fine. Oh, I know why. It's not cutting the view. Hang on. Don't worry, guys. You'll get here. There. All right. So I draw that wall, and it's got some really smart stuff in it. It's not just a line, but I drew it like it was a line. So that is an architectural family. Technically, it's a system family. Well, you know, system families are kind of hard-coded and stuff, but that is a family. It's a wall, but it's a family. Just like when I create a column, you know, that's an angle, steel angle. It's a family. It's a structural family. Or, you know, a stair or a roof or beams or columns, you know, whatever the case is, these smart elements that we build are families. Let's see here. I guess let's kind of go through systematically and just kind of understand that, right? So architecturally, we have walls, doors, windows, right? Like the typical stuff you would think of. Stairs are on there. Curtain grids, mullions, right? Like all these architectural things that we've been talking about that you've modeled at some point in Rhino are here in a way. But we also have these things here called rooms, right? So we build 4 walls and we drop a room into those 4 walls. And that room basically spills out to the maximum boundaries of those walls and creates a space. And that space, believe it or not, has parameters. And those parameters can be used to program information, like what is my floor material? What are my wall materials? What's my ceiling treatment in this space? And then you can easily put that into a schedule. Okay, so like I said, I'm not trying to teach you everything about it right now, but I want you to know where we're going and why we're going there. So without getting into too much stuff on architecture, let's look at structure. We have the typical stuff, you know, just like we had walls, doors, windows. We have beams, walls, columns, floors, trusses, braces, beam systems, right? Like all these things that are your typical structural elements, right? The stuff that holds all the other architectural stuff up. There's a lot more, you know, intense stuff that we won't use as much, like rebar. I doubt we're going to get to actually designing and modeling rebar in this class, but you can do it. You can model literally everything down to the light switch on the wall, which we do in our office. So yeah, anyway, so that's structure. Annotation, well, let's look at systems, okay? So systems is all of your mechanical, plumbing, and electrical stuff and other miscellaneous disciplines. But, you know, duct work, the mechanical equipment that goes on the roof, right? All of your piping and fixtures, right? All of that stuff is hard-coded into Revit. So, I mean, literally, like when you're talking about what Revit can do, you model all the systems. Like that projector is modeled. These lights are modeled. That diffuser is modeled, right? This whiteboard is modeled. And when we put all this stuff together, like the duct run that goes to this versus the mount connection to the structure above that, right? Like if the duct's going across that way, and then the structural connection for the projector is in its way, you can run a clash detection in like Navisworks or something like that. Revit doesn't do the clash detection, unfortunately. But it will tell you. It'll literally spit out a list that says you have these 1,112 things that you need to fix. Right? It's pretty amazing. So real quick, I'm just going to kind of jump into Google and show you what clash detection is. So we were talking about that. Clash detection. Yeah. All right. So basically, you can run the clash detection. All these things are modeled. and you can see like there's a sprinkler head popping out here, there's a pipe going through the duct there, and that just happens at the touch of a button. Cool stuff, right? Well, we won't be doing clash detection, but the reason I want you guys to have a certain respect and affinity for all the other disciplines modeling their stuff too, and the accuracy of modeling, is because of stuff like that. You'll get there in your career, I promise.
Is that another plugin for?
Yeah, so basically the Revit models, like your model, your consultant models and stuff, they all get put into the software, and then it just runs like one model versus the other, and it just tests whether or not they're coincident. Yeah.
What's it called?
Clash detection. All right.
One other question.
Yes. Don't ever be sorry.
You're saying that each space has to have a room.
It doesn't have to, but it
So
can.
you don't have to use you're dropping a room into a space. Is that
Yeah, actually, this is a room.
correct?
Yeah, so since we're on that subject, yeah, you don't have to have a room. If I delete that, the model's still there. I just won't be able to tag that with an easy tag that says, this is the kitchen. I'd have to type it in. Does that make sense?
Yeah.
But now, since that is there, right, let me get rid of that. All I have to do is go to the architecture tab, go to tag room, boom, kitchen and dining room. And you know what? That information is already programmed into the room, so if I need to show more information, I just switch the tag type to room tag with area, and there it is. Yeah. And believe it or not, guys, like these tags, they're also families, right? They have parameters. Those parameters come in the form of labels and geometry. So, like, everything is just parameters and families the whole way through.
So Revit also has its own library of families. You don't have to go download.
It does. Yeah, the standard Revit families are pretty good and fairly expansive. What I find is, generally speaking, they're very generic. So, and sometimes you have to update them for code reasons. But a lot of times, like if you're working in the architectural field and somebody specifies a certain piece of equipment, usually you can download from the manufacturer that piece of equipment, which is usually the way you want to go. Like, let's say I want to add a sink right here, right? That sink is a family. Oh, by the way, we were talking about MEP stuff. Well, you see these little call outs here? That says 15.3 millimeters out. That's the diameter of the pipe that goes out, and that's the connection point. This is, or actually it's more than that. It's like, I can't read it, but this is like 95.3 millimeters out. That's the diameter of that one. Okay, so this information, like you provide the family is built with a parameter for that connection point, and then the plumbing engineer will actually model that pipe up to that point, and it gets connected. Does that make sense? So anyway, if I
Change the units too, right?
yeah, we can change the units to inches. We will in our project. We're going to be working in feet and inches. So anyway, if I need to create another sink, actually let me do this the typical way. So I need to go to component, and then I open up the list here, and these are all the families that are preloaded into my project. This isn't all the families that are available to me. These are just the ones that are loaded in my project right now. So I'm going to pick, I don't know if there are other sinks, but look at this. I can just search for sink. That didn't exist in the last version of Revit. So I'm like so stoked that I can now search for this stuff. Before you'd have to like scroll. So it's getting even smarter. So it looks like there's only one sink, but maybe let's add, what's another kitchen thing we can search for? Yeah. All right. So let's say we want a pasta faucet or something like that. You guys know what a pasta faucet is? Yeah. So I just added a pasta faucet. Well, it's not showing up for some reason. What is this? What set is this in? Oh, I know why. It's in like, there you go. It's in millimeters or something. So I don't know my English units that much. So yeah, so we added a pasta faucet. So yeah. Cool stuff, right? All right. Any questions on that so far? All right. So real quick, I guess. Well, I guess we don't really need to model site elements, but I do want to show you just that the model really is kind of this overall 3D element, and all these families that we're working with. The way I like to work is with a 3D view open on one side, and then my active working views on the other side, and then I just kind of like I'll work in 3D frequently. So that pasta faucet that I put in there, I'm like looking at it, I'm like, that's not really right. I think it needs to go a little higher. So let me 1500, something like that, right? And it jumps up. Does that make sense? Pretty easy and simple stuff. Yes.
So are you importing the topo and the ground condition? How does Rhino handle that?
Yeah. So Revit with site elements is not amazing. It's all right though. I think that's one of their weak spots. Is I would really love to take like a GIS survey and just say, here you go, Revit, make it happen. But I think right now, I mean, as far as I know, unless updates have happened in the last couple years, it's still pretty much like you kind of have to model it yourself. And I'll show you like the editing of this surface. It's really just a bunch of control points. These control points have like, oops, sorry. They have specific data tied to them. And like if I want one of these points to go a little bit higher, I just need to change this. Let's go to like 5,000 and it jumps down. See that? So it's a little bit manual at the moment. I don't really like it. Oh, that's really dark up there. Hang on.
So how do you actually get the topo in?
We'll talk about that. Like basically what I do for mine is I'll take a CAD file and I'll link in a CAD file and then I'll just go point, 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 like along the thing, and then I'll select them all and put it at the right height. Yeah, for really complex topos, it's really not efficient. I'm sure there are better ways out there. For some reason in my career, I've mostly worked on flat sites, so I haven't had a need to become an expert in it. Yeah, but we'll work on some topo stuff for sure. Yeah.
Is there a way to change your perspective view to make, I don't know what the right word is to describe that, but like on Rhino, you can change that value.
Yeah,
so
good question.
it's wider?
So the question was, is there a way to change your perspective view? In reality, right now we're in parallel projection. That's kind of another Revit weak spot is that it's not awesome at perspective. So what what you can do is you go to view, you go to 3D view, and you put a camera down somewhere. And that's probably going to shoot me off the wrong direction, but you can look at it that way. But navigating that space is really kind of a pain. So you use third-party software like Enscape. Are you familiar with that? Okay, I'll show you real quick. Enscape. Enscape is basically, they're just going to show you the pretty pictures, of course. I guess it could kind of look like that, right? So it's a Revit add-on that real-time renders your file. So as you're working in the Revit environment on one screen, that screen, usually we have two screens like this in most offices these days. You put Enscape on one, and you can basically like just walk around your model like this in real time. So if I remove this rail in Revit while I'm running Enscape, that rail goes away in this rendered view. Just, it's like a real-time, it's like a video game environment. And Enscape's not the only one that does it. Lumion has one as well.
Is that pretty costly in terms of memory, for your memory?
Yeah, you've got to have a pretty steep graphics card. The RAM isn't that big a deal anymore. It's all graphics card based nowadays. Yeah, I'd be for something like that. You need like a GTX 10 series or something like that, like a 1050 or something or more. I mean, I would run it on a 1050 or more, but you could probably get away with like the 900 series. Something like that.
And 8 gigs of RAM would do it?
Most, I would say you want 16 as a minimum these days. I think even Revit requires 16. Yeah.
What do you mean by that?
Oh, sorry, graphics card and NVIDIA graphics card.
Yeah. But I think even Revit requires 16 gigs nowadays. I would say, I mean, you almost can't even buy a laptop anymore without 16 if you're gonna. I mean, unless you're going for like a word processing web browser laptop.
Of all the renderers that I use, I think Maya has the best rendering engine
Maya?
by far.
Yeah, Maya's incredible. So
When we first rendered.
yeah, Maya is like a super high-end visualization software and animation software. It's used for like Pixar movies and stuff like that. It's really incredible. Okay. In fact, I think Cloudy with a Chance of Meatballs was like almost all done in Maya.
That's what I do.
I think so.
Final Fantasy Advent Children
Was it? Yeah. Yeah, guys. So anyway, that's kind of like the overall UI look. Keep in mind that as we roll along, there's going to be like these weird, not weird, but there are going to be these little things that I didn't tell you today that is a user interface element. It's just, it doesn't make sense to tell you everything about the interface until you need it. Does that make sense? I think that that's the best way to learn this level of information. Okay. All right, let me stop this video because it's probably like a half an hour long now.